Welcome to Summarize Science, where we break down complex research for you. Have you ever wondered what the universe was like in the very first fraction of a second after the Big Bang? It's a time we can't see with telescopes, but scientists believe we might be able to hear its echoes through gravitational waves. Gravitational waves are ripples in the very fabric of space-time, and they can carry information from the most extreme events in cosmic history. This new research paper explores how a chaotic period right after the universe's initial rapid expansion, known as inflation, could have created a very specific gravitational wave signal. This violent transitional phase is called preheating, and it's when the energy that drove inflation was dumped into the universe, creating the particles that would eventually form everything we see. Using complex computer simulations, the researchers modeled this preheating process. In their model, the main energy field from inflation, called the inflaton, started oscillating wildly after inflation ended. This oscillation did two incredible things at once. First, like pushing a swing at exactly the right moment, it caused its own fluctuations to grow massively in a process called parametric resonance. Second, these oscillations violently kicked a second, lighter particle field. This caused the second field to experience short, intense, and explosive bursts of growth, a phenomenon known as tachyonic instability. All of this cosmic violence, with two different processes happening simultaneously, would have churned up spacetime, creating a powerful background of gravitational waves. And here's the most exciting finding from their work. The gravitational wave signal produced isn't just a single hum, it has a unique double peak structure. The simulations show a strong, dominant peak at a lower frequency, which comes from the main field's resonant shaking. Then, there's a second, smaller peak at a higher frequency, which is the distinct signature of those explosive tachyonic bursts from the other field. Think of it like a cosmic bell that, when struck, produces a main tone and a distinct, higher-pitched overtone. This multi-peak structure acts as a specific fingerprint, a clue that could tell us exactly how the universe's first particles were created. The researchers calculated what this signal would look like today after being stretched out by billions of years of cosmic expansion. They found the main peak would be at an ultra-high frequency, around 10 megahertz, far higher than what detectors like LIGO are designed to hear. While the predicted signal is too faint and at the wrong frequency for our current instruments, the research provides a clear target for future experiments. So let's recap the key points. Scientists have simulated the chaotic end of inflation and found that the interplay of two different resonance effects creates a unique gravitational wave signal. This signal has a characteristic double peak structure, which acts as a fingerprint for this specific moment in cosmic history. If a future detector could find a signal with this exact fingerprint, it would be like hearing an echo from the first moments of creation. It would give us an unprecedented window into the fundamental physics that governed the birth of our universe. This work essentially creates a treasure map for future gravitational wave astronomers, pointing them toward a potential signal from the dawn of time. Thanks for watching this episode of Summarize Science.